Given question: a machine weighing 100 kg is supported on 4 springs. It has 80 mm stroke and it runs at 1000 rpm. If the springs are symmetrically placed with respect to center of gravity of machine. First question: neglecting damping, find the combined stiffness of the springs in order that the force transmitted to the foundation is 1 by 25 times the impressed force. Second question: it is found that the damping, however small, reduces the amplitude of successive vibrations by 25%. Under this condition, find force transmitted to foundation at 1000 rpm. Third question: with small damping, find force transmitted to foundation at resonance.
This is the question for forced vibration with reciprocating unbalance. Let us understand the given data with the help of diagram. Mass of the machine capital M is given 100 kg. Mass of reciprocating parts, that is the reciprocating unbalanced mass small m0 is 2 kg. The system rests on the 4 springs and these 4 springs are parallel to each other. So how to find out the equivalent stiffness? So we have to add the stiffness of all the springs. So we can say that K equivalent is equal to 4K. Now the stroke length is given. So what is the stroke length? So when the piston moves from top dead center to the bottom dead center of the cylinder, that is from the TDC to BDC, then one stroke length L is getting completed. And the stroke length L is equal to 2 times of crank radius. Now we can say that here L is given 0.08 meter and L is equal to 2 times of E, because if we observe the diagram, crank radius is given by letter small e. So how we can calculate this E? So E is equal to L by 2 and which is equal to 0.04 meter. Now zeta is equal to 0 and we have to find out the equivalent stiffness, that is K equivalent. Now the speed is given, N is equal to 1000 rpm. So from that we can calculate the value of omega 2 pi n by 60, which is equal to 104.71 radians per second. Now one statement is given, transmitted force is 1 by 25 times the impressed force. Now why the force is impressed? So if we observe this diagram, the force is impressed due to reciprocating unbalanced. Now how to calculate this impressed force FO? So FO is due to the reciprocating unbalanced mass. So we will calculate FO is equal to this m0 E omega square. So m0 is 2 kg, E is 0.04 meter and omega we have to take its a square, that is 104.71 square. So when we take this formula, FO is equal to m0 E omega square, then we will get the value of FO 877.28 Newton. Now the ratio of Ft by Fo, that is nothing but transmissibility, and which is equal to 1 by 25. So we will get here Tr is equal to 1 by 25. Now it is also given that the statement about the successive amplitude. So successive amplitude reduces by 25%. Now if we consider the first amplitude x1 is equal to 1, then the second amplitude, that is x2 is equal to, so it reduces by 25%. So 1 minus 25%, that is 25 by 100. So 1 minus 0.25, that is equal to 0.75. So when we assume the x1 is equal to 1, then x2 is equal to 0.75. So how we will consider the ratio of successive amplitude, that is x1 by x2 is equal to 1 by 0.75. Now we will calculate combined stiffness of the spring, that is K equivalent. We have formula transmissibility is equal to magnification factor under root of 1 plus 2 zeta r bracket square. So we will first put the formula for this magnification factor ohm. So it is equal to 1 divided by under root of 1 minus r square bracket square plus 2 zeta r bracket square, and this square root term as it is. Now for this case we know that damping factor zeta is equal to 0 because damping is given as a negligible for this question. So when we put zeta is equal to 0, then these two terms will become 0. So we can write here transmissibility, that is 1 by 25 is equal to 1 divided by under root of 1 minus r square bracket square. Now this square and square root is getting cancelled. So which is equal to 1 divided by 1 minus r square. Now we will try to find out the value of r. So we will take here the cross multiplication, that is 25 is equal to 1 minus r square. So if I transfer this r square to the left hand side and this 25 to the right hand side, then r square is equal to minus 24. So there is no any square root for the minus sign, so this is not possible. So what is the other way? Now if we observe, we have taken here 1 by 25 is equal to plus 1 by 1 minus r square. So we can also take 1 by 25 is equal to minus 1 by 1 minus r square. So when we try this, that is with minus sign, then again we will make here the cross multiplication. So 1 minus r square is equal to minus 25. So again we will simplify this. So we will transfer this r square to the left hand side and 25 to the right hand side. So r square is equal to 26 and r is equal to 5.099. So value of r, that is nothing but the frequency ratio omega by omega n. Now we know the value of omega that we have calculated 104.71. So omega n is equal to 20.53 radians per second. So this is the natural frequency. Now how to calculate this omega n? So we have also calculate omega n by using formula in terms of spring stiffness and in terms of mass. Now for this case we have to consider equivalent or combined spring stiffness and mass, that is the mass of the machine. So here omega n is equal to under root of K equivalent by capital N. So when we put value, K equivalent is equal to 42.17 into 10 raised to 3 Newton per meter. We will move to the second question. Force transmitted to the foundation at 1000 rpm. That means we have to find out the value of Ft. Now we have given that the ratio of successive amplitudes with small damping. So when the damping is very small, then the ratio of successive amplitude x1 by x2 is equal to 1 by 0.75. So we will find out the value of delta by logarithmic decrement. So the logarithmic decrement formula is applied to the successive amplitudes, and formula is delta is equal to 1 divided by n minus 1 log to the base e x1 by x2. Now here first amplitude with suffix 1 and final amplitude is with suffix 2. So value of n is equal to 2. So when we put the value 1 divided by 2 minus 1 log to the base e x1 by x2 is 1 by 0.75. So when we solve this, that is log in bracket 1 by 0.75, with the help of calculator we will get the answer 0.2876. So this is the value of delta. Now the small damping is provided, and that's why this is the ratio of successive amplitudes. So whenever the damping is provided, that means there is damping factor zeta. So how to calculate this zeta? So with the help of this delta we will find out the value of zeta. So zeta is equal to delta divided by under root of 4 pi square plus delta square. So we will put here the value of delta and we will find out damping factor zeta is equal to 0.0457. Now we will use the value of zeta, that is damping factor, to calculate the transmitted force. So how to calculate this? So we know that transmissibility, that is Ft by Fo, is equal to magnification factor under root of 1 plus 2 zeta r bracket square. Now this magnification factor is having value 1 divided by under root of 1 minus r square bracket square plus 2 zeta r bracket square, and this term as it is. Now we will put the value of r as well as zeta. So r is 5.099 and zeta is 0.0457. So when we put these values, then we will get the answer. So here Ft divided by Fo. So Fo we have calculated 877.3, which is equal to, now for the first term answer is 0.399 and under root of we have to write as it is and we have to solve this square root term. Now when we solve this, then we will get the answer Ft, that is the force transmitted to the foundation, is equal to 38.6191 Newton. Now we will find out force transmitted to the foundation at resonance. So at resonance, system vibrates at its natural frequency. So we have to consider the omega is equal to omega n, and for the calculation, instead of omega we have to take the value of this omega n, because the system vibrates at its natural frequency, and the frequency ratio R is equal to omega divided by omega n, which is equal to 1. So we have formula Ft by Fo is equal to magnification factor ohm square root of 1 plus 2 zeta r bracket square. Now for this magnification factor, we will put the formula 1 divided by under root of 1 minus r square bracket square plus 2 zeta r bracket square, and the second term as it is. Now we have to put r is equal to 1. So for all these, when we put r is equal to 1, then this first term will become 0 and the second term it will become 1 divided by under root of 2 zeta bracket square. Now here the square and square root is getting cancelled, and for the second term it will become under root of 1 plus 2 zeta bracket square. Now we will write, or we will simplify the next step. So Ft is equal to Fo multiplied by 1 by 2 zeta under root of 1 plus 2 zeta bracket square. Now how to calculate this Fo? Because we cannot take the previous calculated value for this impressed force Fo, because at this time we have to consider natural frequency, that is omega n. So Fo is equal to m0e omega n square. So m0 is 2, e is 0.04 and omega n 20.53 square, which is equal to 33.74. So this step is important. So here Fo we will put 33.74. Value of zeta is 0.0457, and when we calculate we will get the answer 370.71 Newton.